Now we are going to discuss how to investigate what's going on in different parts of the interval of random values. For example, what's the range for 50% of most common values, or 5% of the largest, or 10% of the smallest, and so on. First of all, we use again sample to get this knowledge, and we will not do any inference, so we will try to take into account the population, but without any inference so far. And the easiest way, what we can do is to calculate a percent of values in our sample which are smaller than the given. For example, we can use this formula which calculates this percent as follows. You take the I as a sample position in the sequence, then you subtract 0.5 and divide to n, where n is a total number of values in your sample. So if we use this formula for our sample, we have n equal to 10. N equal to 10. So this is 162. The position is 1. If you subtract 0.5, we will get 0.5 here. Then 2 minus 0.5, we have 1.5. We have 2.5. We have 3.5. And so on. Now we divide it to 10. So we just divide it to 10. So we get 0.05 here, and 0.15 here, and 0.25 here, 0.35 here, and 0.45 here. So if we take the 0.45, it means that 45% of the values are below 176. However, you can see that, for example, if we take the first 162, we've got 5%, but we don't have any values smaller than 162 in our sample. So there is a sort of contradiction here. The idea is that if sample is small enough, then if you take another sample, there is a good chance that there will be some values that are smaller than that, or for example, larger than 188. Let's say that you have a bigger sample, for example, n equal to 100. In this case, if you calculate this quantile for 162, it's again 0.5 divided to 100. You will have less than a 1%, so it's 0.5% only. So once again, this formula just takes into account that the sample is small and there could be a chance to find in the population to find values smaller or larger than the mean and max of this sample. So if we continue all these calculations, we will get this values. So we can say that, for example, if we take 178, so it means that 65% of the values are below 178. Okay. I must say that this formula that we use is not the only one that exists. Actually, there are at least 9 methods to calculate, to use a sample for calculating these quantiles. I'll show you some of them. So you can see this is the simplest one, I divided to n, where I is a position, or sometimes it's called rank of a value in an ordered sequence, and then n is a sample size. Then you can use I minus 1 divided to n, I minus 0.5 divided to n, which we used before, and so on. Let's say, for example, we have n equal to 10, and then I equal to 2. So it's a second position. So it's a second value, second smallest value in our data. So in this case, it will be 2 divided to 10, which is 0.2, right? So it's a 20%. In this case, it will be 2 minus 1 divided to 10, so it will be 1 divided to 10, which gives us 0.1, which is a 10%. So in this case, we will have 1.5 divided to 10, which gives us 0.15, which is 15%. Then we can just continue. Here we will have 2 over 11, which is slightly smaller than 0.2. And here we will have 1 over 9, which is slightly larger than 0.1. Okay, but as soon as our sample size is large enough, so the result will be almost the same. So in fact, it's not a big difference which formula to use. It's mostly important that you use the same formula for all your calculations. In this course, we are going to use this formula. Okay, if sample size is 10, for example, and if we use the formula that we discussed before, that's the quantiles for our sample. But what if we want to find, for example, I don't know, 20% of the smallest values? We don't have 20 here. How to find this value in our sample, in possible sample, or maybe possibly in population, which gives us this 20%, the border for 20% of the smallest values. Well, this is called percentile. So percentile is a value below which a given percent of observations fall. For example, we can say that like 162, it's a 5th percentile, because we assume that 5% will be smaller. 168 is 25th percentile, 181 is 75th percentile, and so on. But what to do if we want to find something in between, for example, 27th or 37th percentile? In this case, we can use a sort of linear interpolation, and let me explain how to do that. Well, first of all, let's discuss how to find 27th percentile. And you see that we don't have 27th percentile here. We have 25 and 35. So 27th percentile is here, is in between, right? So what we do, we take this interval, the small interval between the 25th and 35th percentile, and try to do some interpolation. Let me show you the basic idea. So we have these intervals, and we work sort of in two spaces. This is a value space. So we have value space. Then we have, let's call it percentile space. Okay. And the idea is that the distance between 168 and 175 is the same as the distance between 0.25 and 0.35. So it's 10% of the values in between. Okay. Now look, 0.27 is here. So we have another distance, right? So how big this 0.27 is from 0.25. And the distance from x to 168 should be actually the same. So that's the linear interpolation we are going to use. So if you take these two distances, the ratio between two distances, the whole interval, this one, and how far the percentile we are looking for is from the left part of this interval, the ratio between these two distances should be the same, both in percentile space and in value space. Okay, so let's use this knowledge. Let's use this assumption to calculate the x, to find the x. Well, so we have 5 knowns and 1 unknown, and we know these two distances. So let's calculate the distances. To calculate this distance in the variable space, we just take the difference between the largest and smallest value, and then we do the same in the percentile space. Then we calculate also a distance between the 0.27 and the left part of the interval, and then the distance between x and the left part of the interval. So we have 4 different distances, and we know that the ratio of this distance to this distance should be the same as the ratio of this distance to this distance. Okay, so let's use that. So we just write a sort of equation. So this is the ratio. This is the ratio of distances in the value space, and this is the ratio of distances in the percentile space. Okay, and now we can use a very simple math to solve this equation and find x. First of all, we can multiply both parts to this 175 minus 168 here and also here. I'll try to do it. 175 minus 168. Okay, so we can get rid of this one and come to this. And now we just need to add 168 to both parts. So we will end up with this formula. And by doing simple arithmetical calculations, we can find that the value we are looking for is 169.4, which is a little bit larger than 168. So this is our 27th percentile for our data. If we look at this again and keep the original formula, you can see that we can actually make it universal for any values and for any percentiles. So we can just substitute the numbers with some letters. For example, x1 and x2 are the boundaries for our interval, where the percentile we are looking for is inside. And p1 and p2 are the same, but in the percentile space, right? Now this is p, this is we know this. For example, this is what the percent we are looking for, and then you have just one unknown x. So by taking the ratio of the distances, we can write down this formula. So if you want, you can just change p2 to p1, x1, x2 to particular numbers, and can easily calculate any percentile using this linear interpolation approach. Now, if you think about percentiles, if you don't take into account decimals in the percentile space, then you sort of split all your values into 100 equal portions. And in the first portion, you will have 1% of the values, and another percent, and so on. If we generalize this idea, so let's say we have an interval, so we have this interval of the values. This is the smallest value, this is the largest value, okay? And then we would like to split this interval into portions. Let's say we have like this, plus this, and this, okay? So if we want to split it to 2 equal portions, so we have 3 values in the left part and 3 values in the right part, we need only 1 value here, okay? So that's the way to split our interval into 2 equal portions. If we want to split it to 3 equal portions, then we need to take this part and this part, right? So we have 2 values here, 2 values here, 2 values here, okay? So the general idea is following. If you have some values and you would like to split them into n regular intervals, so the amount of values is the same in each interval, you need n-1 points. And this n-1 points are usually called quantiles. Depending on the number of intervals, there are some particular names for the quantiles. For example, if you split your values into 2 equal portions of 50% and 50%, it's median. Okay, that's what we already know. If you do it for 4 portions, for example, 25%, 25%, 25, and 25, that's these quantiles are called quartiles, from 1/4, 1/4. Okay. If you do it with 10 equal portions, then you will get deciles. So you have 10% values, another 10% values, and so on. Then finally, percentiles, we know already that is when we split our values into 1% portions, 1% segments. I must note that when we talk about equal portions, it's not means that the intervals will be equal. No, you can see that the intervals are not equal if we work in the value space, but the amount of values is equal. So we have 2 values here, 2 values here, and 2 values here. So they are equal from this point of